We will now move into our panel discussion. I have a question that I would like to pose to all our panelists. As the demand for sustainable construction practices grows, how do you see the HPC contributing to sustainability goals within the construction industry? I think we can start with Chaubey sir.
The sustainability is basically as defined in the Kyoto Protocol. It is sustainability is the development in our society without compromising on the development capability of our future generations. We do not use up the resources so much that our future generations are not able to. They do not have enough resources left for their own usage. Now, when I say this, high performance concrete, high performance concrete is able to give us, a higher amount of utility for the same amount of resources that we are using. So, if I had to tell you an example, like in Thane, the population which is staying, say 1 lakh or 1 crore, if I had to have, small buildings, small houses for each of them, the resources, the cement or the aggregates or the concrete that would have been required would have been much higher. And also imagine the transportation cost, because there is just one resource, one source from where the aggregate, where the cement comes. It has to be transported to all the parts. So the cost of transportation, the cost of energy that is required for manufacturing these materials, it actually is much higher as compared to the cost that you would be incurring for constructing a high-rise building or a structure which is long lasting. So let us say durability. If I want a high performance concrete which is more durable, so if a structure, a bridge which falls within every 20 years, the resource required, for construction of that bridge or servicing the society would be much higher. You would be using more resources. It would be less sustainable if you were not having high performance concrete. So this way, high performance concrete using is actually creating more sustainability. Apart from this, if there is any other panelist, I would request if they can add more points.
Rishabh sir, can we have your take on this?
See, I believe the major component in HPC is, let's say, a cement. And of course, the production of cement is, increasing some amount of carbon footprint. So I believe there might be, or there is a necessity of using the additional supplementary material or SCMs more into the, for the high performance concrete to be the sustainable, because it wouldn't be like that. Like if we, use like what Manish told earlier, it is not about only the strength, it is more about what we exactly plan for. So, for sustainability, like environmental and sustainability standards, what I have explained in my regulatory compliance as well, to reduce the carbon footprint and for the safety of the workers as well. It is not like, using the materials which are more sustainable, but which are very difficult in handling or placing, or which is very difficult in, for the construction crew, because at the end they are going to do everything on the site. We are just here to guide them. So, the materials which are easy to procure, easily available in the market, easy to use it, easy to apply it, and altogether which are easy to regulate in the bylaws or body, then only it can be feasible. Just a single one line answer cannot, for sustain. So sustainability is a very, as I discussed in OSHA guidelines or PP safety kits, or let's say lead or carbon footprints, altogether compatibility of a material with respect to every parameter. Again, the cost, upfront cost is higher of what the conventional concrete is. So in all the cases we have to think about the sustainability, because if we are spending more cost initially for any project, of course we are not aware 100% guarantee about the long-term performance of the HPC. Let's say the 20 years back someone has used the ultra high performance concrete, and today we are evolving it. When we are doing the condition assessment as well, For conventional concrete, still many data is not available, or we are doing the analysis by big data theory, by using the predictive maintenance, or prediction of the upfront problems. We are doing the prevention practices. So HPC is somewhat very different than what the conventional concrete is. So if you are planning for the sustainability, then cost implication, environmental implications, construction handling or mixing by the workers, all these things that needs to be worked out.
Please, sir, you want to add something?
If we look at sustainability, as it was said, it is not just about what we are doing today, but it is also about what happens tomorrow. So let us say I am constructing a bridge in the sea, Bandra-Worli Sea Link we have constructed, and we are very proud and happy about it. We cannot go and do that every 25 or 30 years. We expect it to last for at least 100, 120. Probably if it goes beyond 120 years, it's a bonus for the society. Because the cost of constructing a Bandra-Worli Sea Link 20 years back, probably it was 1,500 crores. If you want to do it today, it would be about 3,500 crores. And if you want to do it 25 years down the line, probably it would be around 5,000 or 6,000 crores. So economics will not make it easy for you to do it again and again. So I need to plan not for today, for tomorrow, and for a long time beyond that also. Based on that, currently we are still evolving in terms of high performance concrete. Evolving, I would say we do have a good idea about what is concrete, what is high performance concrete, but the applicability, if we really want to look at it, from the point of view of, I would say there are two major industries in construction that we look at: the private sector, or the real estate and that commercial sector, and government infrastructure works that we do. In the private sector, to a large extent, the understanding of fly ash, more than understanding, it is very easy to absorb the idea of new concrete technologies, fly ash, GGBS. But in infrastructure industry, even today, from the government agencies, we still have a lot of resistance when it comes to using fly ash and GGB. Their thought is the contractor wants to use it because it will save him money, which is a completely wrong idea of what is, because they are saying कि आपको fly ash use करना है because it is of lesser cost, you are going to save money. So if you want to use fly ash, you give that benefit back to the project. It doesn't happen like that, because when I'm quoting considering that I'm going to use fly ash. So I've already quoted considering the cost of fly ash, not the cost of 100% cement. However, when we are not allowed to do that, we are not allowed to build a high performance concrete structure because of certain mindset of the client. What I am delivering at the end of the day is not a high performance structure, though many clients are now changing, and it is moving towards that kind of concrete use in infrastructure also. But we still have a lot of, so that is one area where we really need to focus and bring a change in the client, where he should allow us to use a high performance concrete which will give us more durability.
Thank you, sir. Mr. Sajin.
I think all the speakers covered the point. I'll add one more point here. By adding fiber, also it reduces the concrete or cement, so not concrete, the volume of the cement, you can reduce it, and eventually the carbon footprint will get reduced also. And another, I would say, error and waste. If there is an error, it's an integration. If there is an error in the mixing or the recipes with the machines, okay, or manual input given to the plant, so there is a chance of waste of concrete. So reduce the waste, or in the other hand, improve the machineries. And also I can say, if there is a returned concrete
or waste concrete, that you can reuse it for by using a machine reclaimer. It's already in India market. So if you reuse it, the resources will become lesser, or not go for waste. So it will be a advantage of limiting the resources to minimize, or let's say, yeah, wasting reduction, in short. Yeah. Thank you.
Thank you, panelists, for your insights. My next question is for Mr. Rishabh. How do you think the current building codes and standards need to evolve to better support the adoption of high performance concrete in large scale projects?
See, existing regulations are not capable enough to use and implement of high performance concrete to the large end products, what I believe. High performance application of high performance concrete from project to project, it's a tailor-made requirement, what I believe. It is not always, it is always depends on supply and demand. Like it is not always 1 + 1 and 2, and then it's a mixed doses. If you are feeling headache, then take a paracetamol, so kind. And so but in existing code, or the codes which I have covered in my presentation for ASTM, AACI and ISO, like properties like rigorous testing, quality control, and throughout monitoring during the mixing, placing, curing and finishing. That is what in construction phase I would like to add these 4 activities. The existing code should be evolved. Another is about the material properties and performance. Like, these are the always specialized material and specialized concrete, what I believe. So their behavior throughout life, we cannot predict in the start. So their behavior with the environment. So what I have said, like chloride ion penetration, or alternate wetting and drying process, freeze frost cycle, so to understand the material properties and their performance in the service life, that is also regulatory, in coming up to be done in the then design and design requirements. So like, specialized design, like, what sir said, like it is not always about the strength, right? So it is, we want to retain the time, so there will be a spatial design requirement. If we want to accelerate the time, like let's say if you are working near the hilly areas where the snowfall is there, many times, so design specific point of view as also it is, has to be done. Again, the like I've got like material ho gaya, design ho gaya, construction process. There should be again a training, on-site training, and SOPs to be given for period to period, because the masons and worker which they are going to do it for a particular project, they are always not used to with the specialized concrete. So it is many times it is necessary to given them a special training. Also, there will be a separate regulatory code for the certification and approval as well. Many times rigorous proof checking to be done by the third party. Many times it's difficult to understand client how it is effective to use high performance concrete for our current project. So additional certification may required in the compliance or existing codes, which needs to be incorporated. Even the approval process, like, I am a structural engineer, and let's say if you talk about the Mumbai, there is one high-rise committee. So if your building specifically cross the height, there is one special committee who sanctioned the, everything further, who will take granted. So like in concrete industry as well, if there is a special concrete, there should be a separate and independent approval, provision of committee should be there. And of course, for any project, benefit to cost ratio analysis to be done. Like in, let's say for repair, for BMC, if we consider 40% more, then we go for the new structures. But many times for a concrete, it's it is always difficult to understand the behavior of concrete throughout the ages. If there is a concrete, there will be a cracks. But if there is a cracks, does not mean always the structure is failure and whatever we have done is wrong. So the cost implications subject to the benefit, that also total things to be done. Compatibility with the existing structures, like retrofitting, we have the code. So many times if we are using the high performance concrete for the existing structure, like say in routine procedure, we are using the polymer modified mortar or let's say micro concrete. But the existing parent grade of concrete is not matching with the current new materials which we are using day-to-day life. So if we are using the high performance concrete with the routing, or let's say for the seismic retrofitting purpose, for dynamic response, what will be the behavior of the high performance concrete in the earthquake? All these things needs to be evolved in the current or the codes which has been coming up in the days to come.
Thank you, sir. Mr. Mokal, my next question is for you. How do you balance the need for high quality aggregates with the environmental impact of aggregate extraction and processing?
When it comes to the high quality aggregate, one first needs to look at what are the sources that are available and what are the clearances that have been given for a. I will talk in terms of the infrastructure project. So whenever any infrastructure project is being envisaged, the client will also give you an idea about what are the probable sources of aggregate, from where it can be purchased, or where you can put up your own crushing plants for production of aggregate. That clearances is given to you by the client. So you have an idea about, so the client has already taken the approvals for the probable source of aggregate. Or sometimes if it is a tunnel project, then we don't have to worry, because whatever I'm going to take the muck out of the tunnel, I'm going to directly use it for my project. So that is one thing. What is more important is how are we going to produce the aggregate so that the overall, you can say the overall carbon footprint is reduced. As I said, if the quality of aggregate is good, if I'm investing a little bit on washing the sand, taking the silt out of it, and putting up a vertical shaft impactor crusher so that the shape and the size of the aggregates is good, my overall cement content significantly reduces. Now, the minute my significant reduction in cement is achieved, I am reducing the carbon footprint, because the carbon footprint of your cement is very, very high as compared to the carbon footprint of the aggregate. So a little bit extra investment in that and achieving an overall carbon footprint improvement is going to be what is the future of how we want to look at the quality of aggregate.
Mr. Sajin Noorjahan, how do you integrate fiber dosing systems with existing concrete plant operation, and what factors should be considered during this integration?
When you integrate with your existing plant, you have to check the compatibility first. For that, you have to choose the right machines, batching plant. Let's say, for example, in India, we did a study, all of the existing software or control system of batching plant, it can easily add or modify with our system. Also, it will be helpful to integrate with ERP system. That is also we can provide with our control system GPE.
Thank you, Mr. Sajin.
Thank you.
To wrap up our discussion, Mr. Chaubey, could you share your final thoughts on the future of high performance concrete?
So the future, the best way to predict future is to actually create it. This is what some people said. I feel the future of high performance concrete is very bright. It's not because I'm saying, but because we are seeing the trend. If you see the trend for high performance concrete that was being demanded somewhere in the year 2000 was much less. It was only for very, niche projects like highways where M60 grid of concrete or, that kind of concrete was required. Slowly, when this more and more population, started increasing in the urban areas, that time this demand for concrete started increasing. And also the what happens is it's not just the demand that, increase in demand leads to increase of any demand of any product, but it is also the capability to supply. So what has happened is, fortunately, the industry has been able to give the required solutions, for manufacturing high performance concrete. So after 2000, we started seeing much better developments in terms of admixture, like high PC, the PC, the polycarboxylate ether. From naphtha, we started moving to PC, which where the water reduction possible was somewhere around 40%. And after that, the cement strength also, if you see, has been considerably increasing. Moreover, if you see, there was more and more increase of microsilica consumption that kept on happening. And what happened was, again, this challenge came that, the microsilica that was required was not available. And it came from a long distance, creating a lot of. So the only, if you see, the closest source of good quality microsilica today is either China or Korea or Japan. But what has happened is, we in India have been able to evolve and develop our own, local solutions, in which GGBFS, we have been able to get high performance from ultrafine GGBFS, ultrafine fly ash, which is available locally, and just processing these materials is giving us much better performance as compared to whatever we got from the imported microsilica. So if you see the trend and the, trend in terms of the demand and trend in terms of the supply, it's matching. And there is consistent, improvement. There is consistent advancement, evolution, whatever you call it, that is happening. So I feel the trend shows that, there is going to be more and more usage of high performance concrete, especially in the metropolitan cities of our country, and also where, this infra projects like long bridges. We have just been able to go and supply this material on Bangladesh border, India-Bangladesh border. There is a very strategic bridge that is coming on Brahmaputra River. So we have been able to supply this material over there. So, it is more viable to supply locally available flash, process it, and supply to a long distance than importing microsilica all the way from China. So this way, I feel high performance concrete is really going to be, in more demand, and we need to be more and more, able to meet higher strength and much higher performance requirements. If you see BRO, the Border Roads Organization, they are trying to work on a project where there is no requirement of reinforcement, and IIT Delhi is trying to work on it. They are working a lot on it. They claim that they have achieved the required performance, but still, the testing process is happening, rigorous testing is happening. So the work is still going on. So this is what I am able to give, basis on my whatever imagination that I can do about the high performance concrete.
Thank you, Chaubey sir. Thank you once again to all our panelists for your valuable insights and engaging discussion. We appreciate your time and expertise. Now, Vinisha will do the vote of thanks.
Thank you, panelists, for your valuable contribution to today's discussion on high-performance concrete, advancement and applications in modern construction. We hope our audience found this session informative and inspiring. For our viewers, your feedback is essential, and we encourage you to stay connected with us on our social media handles for updates on future webinars and events.